Hello, here's a quick how to use a video for the HUMS House Water Monitoring Network. Um, First, I'm going to take you on a brief tour of a couple of servers, which one is the one that's located in the HUMS house. It's a Raspberry Pi, and that's the controller that connects to the little remote computers by a wireless network that it hosts itself. The second one is a server inside the Texas Tech logical network that physically resides in my office, and I've set up some scripts so that that server, through its web browser and some other features, can communicate with the Raspberry Pi server in Junction and retrieve data. And so the point of this video is both to show those scripts, hopefully provide an initial layout, and give you what you need to be able to access data. So first, let's take a tour of the actual network. I have some windows already open. Let me bring them to life. Okay, first is a server called Theodore-Odroid.ttu.edu, and I think its IP number is 129.118.20.1. Let's find out. Close, 129.118.20.165. That's a university served IP number. It's pretty stable, so if you want to write that down for future access, in addition to the domain, the DNS entry of Theodore-Odroid.ttu.edu, you're good to go. I'm currently logged in as user 1. This particular machine has 4 users that can log in. There's root, there's user 1, there's user git, and there's one more. I can't remember what the other one is. It's probably Odroid. Yeah, I think there's probably a user called Odroid. But this server has scripts to access the Raspberry Pi server. So let's go take a look at a few of those real quickly, and then we'll actually run them. We'll run them through a web interface. So scripts are located in a directory that you normally won't have access to. User library, CGI bin, test scripts. Let me list them out. Okay, so there's one test. There's a couple of them that are Python scripts and a couple that are shell scripts. We're going to look at first the script called get and packtron.python. That's this one right here. And that script executes as www-data when it's called from a web page. So we'll just go down through this script. Less will work. So it's slightly documented. It uses the Python subsystem, and the Python subsystem on the CGI bin, I believe on this computer, it looks like it's a 2.7 version because of the way the print statements are working. It imports some modules. It gets some inputs from the field. All I did was copy another script that does something different, so the part that grabs the input is never used. It determines what the current system time is. That's somewhat important because it appears when it retrieves the data from the Raspberry Pi, the file dates are associated with whatever the date and time is on the Raspberry Pi. And so if the two times get too far out of sync, I think it's going to start creating errors and just not work. And then what this Python script does is prepare some HTML. But the real meat of it is right here. Where we're instituting a remote procedure call, it's going to run a script called get and pack shell. That script is designed to run as www-data, that's the username, but that particular script is allowed to run as root. And that's really important because in that script it essentially secure shells to the HUMS house computer and then executes a script that's already on the HUMS house computer called get remote, and then prepares the data for downloading. So let's look at the shell script that it actually runs. So here's the actual work that goes on. So when we execute the packing function, it's going to secure shell to the Raspberry Pi computer, which is address 129.118.101.129, and then it's going to execute on that computer remotely the command get all remote .shell, and any output from that, standard output, any error is sent to a null device, so it just disappears. Once that's complete, that's what the semicolon does, is essentially wait until it gets to the end of the script. Then it's going to run a second script where it secures shells again to the Raspberry Pi. In this case, executes a command home pi smart house pack remote .shell. Again, standard output and error is sent to null devices, and it waits until it's done, and then this script is completed. Upon successful completion, the data is now prepared on the Raspberry Pi computer for retrieval to this computer. The retrieval is executed using the update tron script. So let me get that one. Here it's again a CGI bin script, so you're telling it to use the Python subsystem. The important module here is the subprocess module, and it runs through, and I tried to build it all in one script, so this commented section probably needs to go away. So we're now this script is running on the Theodore Odroid. And the first things it does is it removes the existing copy of a tape archive called remote.tar that lives in var www.html documents smb share user1 tronnet database. So the subprocess runs that command and deletes the copies. So the only viewable copies of the tar file will be whatever the most current one, the most recent downloaded one is. Then it retrieves the pack files into the database. And so this is another, so the next thing it does is it retrieves the packed data files from the Raspberry Pi using a wget command, a webget, and then the dash capital P says take the contents of the wget and store it in a particular place, which is var www.html documents smb share tronnet. So that will get the current remote tar file, which is different than the local one we just deleted. Then Once it's completed that, it extracts that file and puts the results. They're going to work right now. Puts the result into the database. The actual reason for this somewhat complicated data retrieval thing is, even though this web address 129.118.101.129 is a routable, I guess that's a class B network address, is routable, for whatever reason it's inaccessible from a public computer. If you're on campus or virtual private networked to a machine that's physically on campus, then you can use the browser on that machine and get to the Raspberry Pi. So because Theodore Odroid, the machine, is physically on campus, I went ahead and wrote the scripts to gather the data to Theodore Odroid, and once it's there, that's publicly accessible. Like we've all joked among ourselves, we have the most secure network in the world. It's unusable. So we won't be hacked by a Russian. So let's go ahead and actually run these scripts. So this machine I'm currently on actually does happen to be inside the Texas Tech network. So to prove this will all still work, let's exit that one. And what was the blue guy? Oh, we didn't do Mr. Blue. This one's actually logged into the suite. All right, I'm not connected to the Raspberry Pi or Theodore Odroid directly. I'm now going to disconnect from the virtual private network. So now I am technically on a public computer. I'm on my home computer. So the website is theodoreodroidttu.edu. It's HTTP. If you attempt to do HTTPS, it won't work. It will fail. Again, that's because IT doesn't allow us to run transmission layer security on our own servers. Apparently only they can do it. So I have to use an unsecured, unencrypted Apache. So we go that, and this should be the main page. And in the HUMS use water metering pull down, since this is all still somewhat experimental, I just put everything here. Eventually I'll get it into a better setup. We have 3 actions we can do, and doing an ordinary update, these are the 3 actions you should take. First, we'll ping TronNet to be sure that the 2 computers are in connection, and this is a correct output. We got both packets back, 0% packet loss. It happened pretty quickly. So what this means is that Odroid can reach the HUMS house. Next, we'll run the packing command. Now, the packing command takes quite a while, 15 or 20 seconds on a good day. So this you have to be patient. This current interface, I'll work on this, but the key thing is the submit. So, example run, press submit query, and it's actually thinking right now. So it's doing those 2 commands. It's retrieving all the data from the Pixar 1s through Pixar 12s onto the Raspberry Pi controller computer, and then it's going to pack that data. And here we have a successful update on the remote. It's telling us it's ready for the retrieve. Error code is 0, and it ran today at 9:35:15 on the Odroid computer, which is 9:36 on my home computer. I actually don't know what the time will be on Raspberry Pi. They'll all be pretty close. They're all running network time protocol, and they update every 20 minutes. So we've now pinged, packed, and now we want to run update. Update runs pretty quickly unless it fails. And same thing. You don't have to enter anything in the remark line. That's mostly for debugging. Hit the submit. And it is just deleted the local copy of remote.tar. It's retrieved the remote copy of remote.tar, and it's expanded the remote copy of remote.tar into the TronNet database, and then it gives us a link to the TronNet database. We're going to go look at its actual structure in a minute. So if all the error codes come back 0, it worked as intended. And here is our database, and let me bring everything up to date. And so it has the correct dates for most of these. Pixar 6, Pixar 8, and Pixar 12 don't exist. So even though it's pulling data and I've created space for them, they'll be empty. But Pixar 1, we can go look at its current status. So these are all start at 3 in the morning, and they run until 2:59 the next morning, and then that 1 minute delay is to let some other automated processes run to be sure files aren't stumbling over each other. And so the current status, the last readings that were stored were at 8:53, which is about 20 minutes ago. The computer's working fine on the remote. There seems to be a little bit of lag time in the sensing and then writing the results. And everything's coming up 0 for the time being because nothing's going on. This happens to be the washer, the clothes washer, the cold and the hot. The structure of all the files is the same. There's a date time stamp. Events 1 and Events 2 are the counts on the Hall detector. Volume 1 and Volume 2 are the conversions of those counts into units of liters. So if you think of these as rates, each of these is liters per minute. Currently the washing machine has been using 0 liters per minute all day. So that's typical for nothing going on. Let's look at Pixar 5 because that wasn't working correctly, and so I've updated it. It still hasn't, it's not done a write to its data file yet, so there's nothing to see here. Pixar 3 was another one I was working with this morning. So today's file has a non-zero entry. I mean, everything, it's still columns of zeros. And again, the last write on that one was at 8:53. Let's just pick another one. See, 6 doesn't exist. Look at 7. Pixar 7 is bathroom number 2, and channel 1 is sink cold water, channel 2 is sink hot water. Again, the counter is not detecting any water flow. Let me go to the prior file so you can see what a completed runtime is. So this started at 3:01 in the morning. Interesting drift. We're drifting about a second every minute. Huh. Started at 3:01 in the morning. Nothing was going on, and it recorded the counts for a minute all day, for every minute of the day, and it's supposed to stop at 2:59, so there's going to be about a 1-minute mismatch, I think, in every file, especially as time goes on. And the way you know it's successfully completed is these last 3 lines where it just says it's time for the process to die, and it totalizes the total events in each channel and the converted volume in each channel. So these would normally be sums of these columns. Okay, and let's just go take a look at the TronNet database. So if we were to access the database without taking the shortcut that's provided in the script, we'd get to here, and there's a remote.tar, so that's the one we just downloaded. Wonder what happens if I don't want to do that. And then remote.tar gets extracted into home, Pi, Smart House, remote data, and so forth. And so what this represents is a image of the Raspberry Pi computer in the HUMS house. And then this is a publicly accessible site, so you could, in your Python script, you could certainly use a wget or curl and access any of these particular files. And I have no intention of changing the file structure. As the as the file count gets large, I may collapse them into individual months by sensor to help maintain storage on the remote. But I'll do that, back it up before clobbering anything on the local in this copy. So this sort of gives us 2 copies of everything. And I think that should be sufficient. I don't think you can actually see these scripts from the web browser. Let's see if we can. Oh, I guess I know what I can do. I'll try to store copies of the actual scripts in TronNet database. Let me see where I'll put them. I'll create an additional directory that actually I'll leave one directory. I'll put a directory here that's going to just contain the working scripts so that you would be able to see them and see the computer logic going on. Okay, that's all I have. I thought the video was a little easier than trying to put all this in writing. That's a long video.